So today I want to talk, well, I titled the talk, One Rule to Rule Them All. And I have to confess, it's good that Ino's not here because she would beat me up for this because I'm not a big Tolkien fan, but it just struck me as a nice title. If you have seen me speak before, you will know that I do not like rules. Never have. For me, a rule is always wrong. A rule cannot be correct because every situation is different. Everything that we do is different. And it's impossible to come up with one rule that will cover any situation you find yourself in. Right? There are almost no universal rules. So I've been pushing back against all of these consultants and everybody else that tells you, this is how you should do this is how you should do that, because there aren't any rules like that. But at the same time, I think this isn't a rule, but it's a really, really interesting suggestion. So let me get away with it. And I'll justify myself by falling back on authority, as people do. You find some random quote on the internet and you use that to justify your opinion. A foolish consistency is the hobgoblin of little minds, which is pretty meaningful. But there's actually a better authority I'd like to call on, and that's Yogi Berra, the baseball player. And I'll be using him to justify most of what I say. And as it says there, I never said most of the things that I did say. So where am I coming from here? And to talk about my rule, I really have to go back in time a little bit and talk about the build-up to this, the history of, actually to some extent, the history of agility, why agility failed, and what we're actually doing now. So let's go back in our time machines to the 1990s. I would ask for a show of hands of who was actually alive in 1995, but that would just depress me, so I'm not going to do that. For those of us, old people, who were developing software in the 90s, we will remember it with a horror, I think is probably the best word for it. It was a nightmare. People were writing software, people were writing a lot of software, and most of it didn't work. Well over 50% of projects never even got completed. The ones that did get completed typically failed to meet their requirements and were short-lived. And a lot of this is because our understanding of how to write software didn't keep up with the amount of software getting written. Back in the 1960s, 1970s, software was largely a localized thing that you wrote, academic or maybe some business systems, but it was really very constrained. And we were still using many of the processes that people were using back then when we were writing software in the 1990s. And over the years between, people had evolved it, but it was still, pretty much the same kind of idea. So there was a classic idea of waterfall software development. Now, this is actually not the real waterfall. The Royce paper did not have, well, actually it did have this diagram, and then it said, this is stupid, and then on the next page, it showed a better version of this diagram. However, people who want to knock waterfall, or people who just want to save time and do, quote, waterfall, tend to use this diagram. And in this diagram, we're actually encapsulating all of the evils of pre-year 2000 software. And the diagram shows pretty clearly what we're thinking here. We're going to capture the requirements. We're going to work out what people want. And once we capture those requirements, then that part's done. Now we're going to move on to designing some kind of architecture. And again, once we finish that, it's done. Then we're going to design our system. Maybe it'll be high-level design, then low-level. Doesn't matter. Each of these is a hurdle that we cross, and there's no going back. So as a result, Here we may be day 0, here we may be 2 years in. And then we're constantly surprised when we deliver software that meets the requirement, but doesn't actually do what the customer wanted. And so there's this extra little step, yeah, we'll do it better next time, but we never do. People realized that they were not writing the software that people wanted, but they put that down to the wrong thing. They thought they were not writing correct software. So they needed to find ways to write correct software. And there's a whole bunch of things that came along to tell people how to write software correctly. We had things like type systems come in, fairly early on, in fact. And type systems were supposed to sit there and say, okay, your program is correct if the types are correct. That didn't quite work out, so we had to put higher order type systems in place. Obviously, that must be better. When I was in college, a really big area of research was theorem proving. And part of the idea of this is, can we actually look at our code and prove it to be correct? And the answer is yes, as long as it's about 10 lines long and has a single loop and a single if statement, because apart from that, it gets just combinatorially too hard to prove. Now, we are actually still doing this kind of theorem proving, but only in very special cases. So things like hardware design languages typically have theorem proving built into them. Some cryptographic code has theorem proving built into it. And then more recently, we've come up with this religion that we call test coverage. And this totally arbitrary and ridiculous goal of 100% test coverage. More programmer time and more programmer spirit has been lost to this ridiculous goal compared to just almost anything else, right? It's ludicrous to think that A, you should have 100% test coverage, and B, that having 100% test coverage is in any way meaningful. It's not. There is nothing in there that guarantees that your software is going to do what the customer wants. So the idea throughout this period of time is that we should be writing correct software. To some extent, this goes back, way back in history. This idea that if we knew all the facts going in, we would be able to predict what was going to come out. So Laplace is famously quoted as saying something along the lines of, if we knew the positions and the velocities of all of the particles in the system, or if some super being knew that, then this super being would be able to predict the entire future of the universe. Nothing would be uncertain, and the future, just like the past, would be present before this being's eyes. Which is clearly wrong. But at the same time, I remember as a kid coming across that, thinking, oh, wow, that's so cool. You know, I wonder if we could do that. Well, no, obviously we can't. If for no other reason than that being would have to be part of the universe it was looking at, and therefore it couldn't do that prediction. But anyway, this is kind of like the philosophy that software has got. If only we knew everything, then we'd be able to produce perfect code. Now, obviously, we can't know everything. Werner Heisenberg showed that you cannot know the momentum and position of a particle. And then Gödel, in his incompleteness theorem, first version is no consistent systems axioms is capable of proving all truths about the arithmetic of natural numbers, which actually comes down to a system cannot demonstrate its own consistency. So even at a theoretical level, we can't know everything when we're writing code. Again, Yogi Berra said it best, if the world were perfect, it wouldn't be. That sounds like one of those, oh, what a stupid thing to say. Actually, if you sit and think about that, it is actually the subject of many hours worth of meditation, because it actually does mean something quite profound. But that's not what we're here to talk about. So, we have been struggling up until the start of the century with this idea of writing correct software. And it became apparent that that wasn't working. So what could we do instead? And so towards the end of the 1990s, a whole group of people were thinking that, maybe that's not what we should be thinking. Maybe we should work out instead how we deal with an uncertain world. How do we deal with a world where we don't know everything, we can't know everything, and therefore we're going to have to write software not really knowing what we're doing? And how can we deal with that? And along the way, you have to make a really big concession. And that concession is, I know that the software I write will not be correct. And initially, that sounds like something major. I'm giving away some major thing here. But I think that's not true. I firmly believe, just based on experience, that there is no such thing as correct code. I don't think in any non-trivial program, anybody in the history of software has ever written a 100% correct program. And I don't think that should worry us, because correctness is not what we're aiming for. Instead, I think we need to deal with this idea that the world changes and our code changes, everything changes, and therefore that's what we should be dealing with. Now, why is the world changing? There was a study probably back around this time, around about the 2000s, that said that in general, for the kind of commercial software that most of us write, requirements change at the rate of roughly 2% per month. Or put it another way, if you were given a set of requirements on January the 1st, and if you were to implement those requirements in code 100% accurately, then delivered it on December 31st, 25% of your code would be wrong, because requirements are changing so rapidly. And that change comes from all over the place. It's external. So obviously, things affect us from the outside. Policy, law, markets, you could read the list as well as I can. One of the interesting ones there is our understanding changes. As we are developing, we are also building understanding of the problem. And as a result, that changes what we want to do. And you may have noticed nature is one of those things that is changing. Internally, we make it difficult for ourselves because we're coming up with new products and new features, integrations that weren't planned from the start. We do things like A/B testing, then we change based on that. We come up with new workflows, we have regulations, all sorts of stuff change. And of course, nowadays, the biggest single change in the software industry is... All right. So things that, well, actually, that's not quite true. There's one more, which I didn't dare put on the slide just in case it read it. But obviously, AI is now representing a major change in the industry and what we're doing. So all of these things happen. We can't stop them. One of the reasons that Yogi Berra's quote about if the world was perfect, it wouldn't be, is that if things are perfect, then by definition, they cannot change. Because any change makes them not perfect. So that's one of the reasons that perfection is death. Perfection is just nothingness. So things that are perfect don't change. Everything else changes. And every good, argument like this needs to have a Venn diagram in it. So here's my Venn diagram of perfection, everything else, and then, oh, by the way, there's no such thing as perfection. So everything changes. So that leads us up to the Manifesto for Agile Software Development. And I would argue that at its core, the Manifesto is all about dealing with change. It's all about how to put in place rapid feedback at all levels and building an organization, lowercase o, that lets us deal with the changes that feedback reveals we need, okay? So you get the feedback to say, no, this is wrong, and now I need to be able to do something about it. So there was a group of us that were just like chatting at a conference, Uppsala conference, I think it was, in 2000, I think. And we all were just doing the normal, oh, everything's bad, blah, blah, blah. If I was God, I would do it this way. And we agreed to get together to just continue this conversation. It was interesting. We were going to meet at the other Dave Thomas's, the real Dave Thomas's villa in Anguilla. But then we thought this was February time, and we thought the idea of telling our spouses that, hey, we're going to go have a real serious conversation in a Caribbean island in February wasn't going to go down too well. So instead we went to Utah, and we came up with this. And it was kind of weird. We actually came up with this part of it pretty much by 2 o'clock in the afternoon on the first day. And then the rest of the time is, well, we've booked the room for 3 days. We need to do something else. So that's where the rest of the stuff came. And to be honest with you, I think the rest of the stuff in the manifesto could just go away. This is the only important part as far as I'm concerned. And we all wrote this, and we all thought it was pretty cool. And we went away not really knowing what else was going on. Ward Cunningham said, oh, we should probably put this up on our website. So he and I put together a website that allowed people to, put their names on it and say, yes, we agree. And that was it. We put it up. I think it was a week later, he emailed me like, we've had like 1,000 signups. I was like, no. And at the end of the second week, it was 10,000, and it just took off. It was unbelievable. Nobody at that meeting expected it to catch quite the way it did. And so over the next, well, until now, I guess, it seems to have taken on a life of its own. There were two kinds of people at the meeting. No, that's not quite fair. Some of the people at the meeting were consultants, and this is clearly something that you consult about. And so they took this on as part of their consultancy practice. Others of us weren't doing that kind of thing, and so we just kind of moved on. This was all done. But as with anything that starts to grow quickly, it became apparent there was money here. And so a lot of organizations moved in to capitalize on the growth of, quote, Agile. And this led to, big consultancies, lots of programs where you can get certifications and various things. And gradually, to my mind, Agile lost this and instead became a set of rules. And what the rules were depended on which consultancy you paid to tell you how to do Agile. And I got kind of frustrated with this. And so at the GOTO in Amsterdam in, yes, 2015, I just vented on stage for 40 minutes. It's actually the first talk where I had people walk out in protest, which was kind of fun. One of them was Jess Sutherland, who was one of the Scrum people. But yeah, and my point there was simply that the word Agile has become meaningless. First of all, you can't use the word Agile in that way because it's an adjective. It is not something you can turn into a noun. But it's become meaningless because it's being taken over by people that basically want to sell you a point of view. And because I tried not to be too negative, I thought, okay, well, let's come back and say, I don't think agility is wrong. I'm still very proud of the things we did in the Manifesto. But what we're doing in the name Agile is not agility. So I came up with sort of it's not an alternative, it's just like a simplification that takes us back to the original ideas. And to my mind, this one slide is all you need when it comes to how to do Agile software development. I view software development as being a bit like trying to walk to a destination that you've never walked to before. Every project is different. Every project is unique. And so you've never done this before. And if you're out walking in the woods and you have to get to some destination, maybe it's a bit foggy and you can't really see where you're going, what do? Do you just stride out and hope to get where you want to get to? Or do you maybe look at a map and think, well, that's exactly 115 degrees. I'm just going to walk 115 degrees for the next 4 hours? No. What you're going to do is you're going to take small steps and you're going to work out whether or not those steps have taken you closer to or further away from your destination. And you're going to correct as you go along. So you find out where you are, you take a small step towards where you're going, and then you pause and you get feedback to work out whether or not this has gone better or worse. And then you just repeat this. And you do this at all levels, from top-level architecture down to naming of variables. All right, this is a fractal thing. And to my mind, that is what you do if you want to write software in an agile fashion. No more, no less. But there's actually a question, and that is, this small step, what direction do you walk in? How do you know what direction to take that step? And I put this thing down because it sounded like a good idea at the time. And that is, when you're faced with two or more alternatives when you're taking that step that deliver roughly the same value, take the path that makes future change easier. And at the time, that was kind of like, I put that in there because I felt I needed to put something in there about how to make that step. But I've come to realize that's actually the most important thing there. In a way, this is what you teach your kids. If you have kids, you teach them. Don't make decisions that you will regret. Don't make decisions that you can't undo unless you absolutely have to. Yeah? If it's a trivial decision, am I going to have chocolate ice cream or strawberry ice cream? Who cares? Just make up your mind and do it. But is it going to be like, am I going to get married? Am I going to have children? Well, maybe you want to think about that because that's really, really hard to undo. Right? It's not something you can just take back. So when it comes to a choice, I think you're typically better off choosing the one that's easier to change. So I think we've gone from pre-year 2000, the need to be correct, And now we have the need to be easy to change. The idea is that we want to be mostly correct today because we know we're going to be updating it tomorrow. Or to put it another way, create things today that can change so they can survive to be changed tomorrow. That, I think, is the prime directive of software development. We are less worried about being correct and more worried about being easy to change when it turns out we're not correct. All very easy to say, but how do we do this? Well, it turns out we're actually doing this already. Let's take a really ridiculous example. We're writing some code, and we have to calculate some kind of tax, and someone writes code like this, and oh, we got another module, so we're going to have to do that calculation somewhere else. Another module, we're going to do that calculation somewhere else. Now, at this point, a lot of you are sitting there going, I know, right? Because it's the first thing that we do when we want to humiliate a new programmer, right? Is we say, never use a constant, never use just a number like that. Always replace it with some kind of constant, because that way, what? I can change it. But even that is wrong, probably, because it's never that simple. So probably what we want to do instead is have some kind of function that does the calculation. Pretty reasonable. And I mean, that's like a progression in terms of design. So we have, this kind of level of things. What is it? Is that just common sense, or is it don't repeat yourself? Well, maybe. But what it really is we've given ourselves a single place to implement both the concept of something and its implementation. And what have we done by doing that? We've made it easy to change. Now, I have a little bit of vested interest in you calling this dry, but that's irrelevant. It's not really. It's nothing to do with being dry. It's just being easier to change. So then we have this wonderful sales module, and we're going to have to write our tax for function that we talked about down here. And tax is never as simple as it looks on the outside. I don't know what it's like in the Netherlands, but in the States we have things like tax holidays. Before you go back to school, typically they take the sales tax off school supplies. And you would not believe how complicated sales tax is in the United States, because not only do you have different sales tax rates for different things, each individual town, county, and state sets its own tax rates. And you have to add them all together to work out the actual tax rate for a particular purchase. And it depends on whether or not the state insists on you taxing at the point of purchase or the point of use, which is another joy. So yeah, tax is complicated. So the chances are pretty good that in our tax module here, we're going to have some kind of rule table. And it's going to say that some of these goods are exempt from tax. We have a tax holiday in certain dates, whatever it might be. So then we have to say, how are we going to change this? How are we going to make this up to date? Because obviously, as it's political, it changes a lot. So maybe what you want to do is to take this code table and move it out into some external form. My personal choice at this point would be to stick it into a Google Sheet or something like that, so I don't have to write the UI and let people maintain that, and then at some point import it into my system. And then if that works, and if people like it, and if it actually does what we need to do, then we can turn it into some kind of web interface or whatever else. But again, what are we doing here? All right? We're modularizing our code. We're splitting our rules out into data. We're externalizing our data, all to make it easier to change. Now we're going to start thinking, well, this code is all like one big lump. We're going to split it up. So we're going to apply things like SRP, and we're going to start doing modularity and all these other kind of wild, cool things that we do with software and justify our ridiculous salaries. And that's great. We end up with some nice looking code. And along the way, we can say that we've done all of these things. All right, makes our resumes look cool. Hey, yeah, of course, I use dry every day and SRP, and I had no idea, a whole bunch of stuff. And then as developers, we're supposed to be able to spout this gibberish and say, this is what we do. This is really good, all right? And your consultants can come in, and part of the test before you become a consultant is you have to memorize at least 50 of these things, and so you can just go in and tell the team, oh, well, you need more cohesion, Cool. But in reality, I don't think you need any of those. Because every single one of them is just a special case of making it easier to change. And if that's the criteria you use when you're making decisions, you don't have to know any of those. I mean, yeah, they're useful hints, but you don't have to know them. So at the coding level, making it easier to change supplants or gets rid of all of those various design tools that we've learned. But it also applies to practices that we do. All of the common practices that we've learned that are good, we should use these. Again, these are just things that make it easier to change. So postulate number 1 is that there is no perfect software. Postulate number 2 is that all design principles and project practices are special cases of make it easier to change. So, finally, after 7 years, 8 years, I've actually managed to kind of come up with something that actually is meaningful for that last phrase there. But I still come back to a question. The idea is we want to make future change easier, but how do you know? How do you know which path that you take is going to make future change easier? And that's what I really want to focus on here, because it's all very well saying, choose the easier path, or the path that's easier to change, but unless you can actually tell which one will be before you set out, that's a meaningless bit of advice. So how do you tell? Well, you could put some money into this machine and it will tell you. But actually, I'll tell you something, you actually already can predict the future. And that is a power that everybody has that we're not exploiting properly in software. Now, I am kind of feeling embarrassed about this because what I'm about to talk about is not the kind of neuroscience that we all marveled at yesterday. Yes or no? But it's still backed by some science and it's still relevant. A brain. So this is totally not a representation, okay? This is just a metaphor. I just thought iceberg was a nice metaphor. But your brain is like an iceberg. And I like to think of it in this way. You have a portion of your brain that you can talk to, that you have conversations with, that you're conscious, right? This is the brain that you're using when you're actually making decisions, whatever else. And then you have 90%, apparently, of your brain, which you cannot access at the conscious level, your subconscious brain. And the interesting thing is, the subconscious brain actually controls you. The subconscious brain is what makes the rest of it possible. So your conscious brain has self-awareness and choice and agency, all the things that we have to think about, we can't do automatically. And then the subconscious brain is handling stuff that we cannot do automatically. Examples. Walking. If you had to walk and think of every single muscle that you have to move, you had to think of the balance that you have to apply as you're walking, you'd never be able to do it. So instead, what you have to do is train your subconscious to do it for you. Because it's fast. It doesn't sit there and interrupt itself constantly, right? All the subconscious is doing is building patterns. And it's doing it all the time, whether you like it or not. It's taking in everything and building patterns based on it. You cannot control it. There's a really weird thing I've noticed. Just try this and see what happens. Try really hard to look at the screen, but do not read what it says. I don't know about you, but I cannot help but read any word I see in my field of view. It just happens. I can't stop it. It's not conscious, it's my subconscious that does that reading. Stop and think about that for a minute. Your subconscious, which is simply based on building patterns, can read. And it's what's reading on your behalf. That's incredible. So all day, we are picking up stuff at the conscious level, and it is filtering down into our subconscious and programming it. We had ChatGPT before anybody else did. All humans, right? Because that's all it is. It's a prediction mechanism. It builds and recognizes patterns. It had a really significant role in that. Because you don't want to sit there and think about, oh, that over there, let me think about that. It's got stripes and, I don't know, it's a lion. No, you don't want to do that, right? You want to have this come up immediately. There's some things that are really quite subtle. You can tell if there's a storm coming, and you probably couldn't tell why. My dog can tell there's a storm coming, way before I can. It's kind of wild. And as developers, we have the same thing. You get this kind of like feeling. This code's wrong. Why? I don't know. How many people, show of hands, how many people have been working on code and there's a bug in it? And you start off, you work on this code, you cannot find the bug. You spend all day working on the code. You work late at night, still trying to find this bug, can't find it. You go home. You are miserable to be with because your brain is still going, what's this bug? What's this bug? Right? You finally get to sleep. And you wake up next morning and you know what the bug was. Okay? Patterns. It's patterns. Your subconscious knows way more than your conscious. There's a couple of cool books about this. thinking fast, thinking slow is all about the difference between the two forms of thinking and how they interact. This book is actually more a warning not to trust these immediate decisions you make. And I can see that, but I actually also think the opposite is true. Because I think we need to learn to use our intuition. Our intuition is how our subconscious gets to us, talks to us. Our subconscious cannot speak, which is ironic because it's what lets us talk. But our subconscious cannot speak to us. It cannot tell us things. So all it can do is make us feel things. It makes us feel nervous. It makes us feel, I want to go that way, not that way. I met my wife in New York. And when we were first going out, we would be walking down the street in New York, and every time, we'd be walking down, and suddenly she would walk into me sideways. So we'd be walking along, and then suddenly it'd be like that. And we'd keep doing it. And eventually I said, "What are you doing?" And she said, "What?" I said, "You keep bumping into me and moving me out." "No, I don't." So we kept doing it, and then the next time I found myself, I said, "Stop, look, right? You just bumped me out." "Oh." And so we tried to analyze it, and it took us a while, but we worked it out. Every time she walked past a doorway where she couldn't see the back of the doorway, she stepped away from it. Totally without thinking about it. She had never consciously told herself to do that. But her subconscious had come up with it as a pattern. And it had done that through experience. That's how we develop our subconscious. We do stuff, we observe the result. There's that feedback coming into it. And just keep doing that over and over. In the mid-1970s, I watched a BBC documentary on Timothy Galway. And most of the documentary, well, not most, a large part of the documentary was watching him coach a woman on, she was having a problem serving the ball. So he came out on court with her. He had a big laundry basket full of tennis balls, put it down the court. Then he went and got a chair and put it on the little tee on the other side of the court. Then he went back and he said to this woman, "Okay, I want you to serve. I do not want you to hit the chair, but I want you to tell me out loud where the ball lands in relation to the chair. Left, right, behind, or ahead of," right? And so she went to the left, behind, over and over. I don't know, there were probably 200 tennis balls in this basket. And when she got down to the last few tennis balls, he said, "Okay, stop." So now your brain knows the movement of your hand and how that relates to the ball position around that chair. So now, I want you to hit the chair. And she was like, "I can't do that." She just do it. Threw the ball up, hits the chair every time. Her brain had learned that this particular set of movements correlates with this particular position of the ball without her consciously doing it. You do something, you observe the result, and that feedback helps train the artificial intelligence that is your intelligence. Coming back to my wife and New York doorways, there's a fantastic book by a guy called Gavin de Becker called The Gift of Fear. Has anybody read that? Oh yeah, okay. So Gavin de Becker, he was, I think he was special forces, and then he formed a protection company where if you were a celebrity or a politician, they would organize your protection. And he became something of an expert on when these people get attacked. And he discovered that without exception, people who get attacked typically think something is wrong before they get attacked. And then they think, oh, that's just stupid. And then a second later, somebody jumps out of a doorway and takes their money or whatever. And his biggest advice, his best advice, his strongest advice to his clients is always listen to that voice. Always listen to that voice because it knows things you don't. All right, so how do we do this in software? I don't know, but here's what I do. And to my surprise, it actually has worked really well. When I'm faced with a choice, I take out a piece of paper, and yes, it has to be a piece of paper. And I pick up a pen, and it has to be a pen or a pencil, and I write down what the change is that I'm about to make, and then I estimate what is likely to be, what I have to do this. And then I go and I make the change. I don't think about this piece of paper. I make the change. When I have finished, I pick this piece of paper back up and I write down the actual effort in whatever units it's appropriate to do it. And if I have any observations, I write those down as well. Cool. Now, I take this piece of paper and I put it in a drawer and I never look at it again. What I have done here is I have made explicit the thing that I want to do and then what actually happened. And my subconscious has noticed that. It's built a pattern. And over time, and it's not long, over a couple of months, I noticed that my estimating was improving. And I put it down to this. Now, a couple of things. If I never look at this piece of paper again, why don't I just throw it away? I think, I've never tried this, I think, that's not true, I did actually do it for a while. If you take the piece of paper and throw it away, you're saying to your subconscious, actually, this doesn't matter. All right, so I think by keeping it, you're actually helping embed it. By writing it down, and here's the really weird one, if you get the opportunity, if you're not in an office full of people, after you write it down, say it out loud. Because what you're doing is your subconscious is basically monitoring all of your inputs. All of your senses are getting filtered down into your subconscious. And they're all used when building that pattern. So the more modes you can use when you're doing this, the better your program, or the faster you're programming your subconscious. So by using a piece of paper and your pen, you're making it tactile. You're reading it. And if you say it out loud, you're both speaking it and hearing it. And all of these things add to the amount of information that's going in to this great big pattern matching engine that you have in your head. And once you've got this going, it's okay now to start listening to your gut. It's okay to start using your instinct, your intuition. Because it's more likely to be right than if you make the conscious choice. And again, there's research on a lot of that. Allow your brain to do what it's best at, which is matching patterns. Or, as Yogi Berra said, you can observe a lot by just watching. So, my one rule to rule them all is make it easier to change. Or, as we all like TLAs, it's ETC. And most importantly of all, please remember to make it fun. All right, I'm done.